Section 1, IPv4 addressing. Just as your personal street address uniquely defines where you live, an IPv4 address uniquely defines where a device resides in a network. So if devices are addressed incorrectly, they may not receive the packets that are intended for them. Therefore, it is important for you to have a solid understanding of IPv4 addressing and how to verify that devices are addressed correctly on a network. So how do you determine if a machine belongs in the same network as another machine? It's based on the IP address and the subnet mask. So an IP address is made up of two parts. One is the network portion and the other is the subnet portion. This can be determined from the subnet mask. The ones highlighted here are the network portion, while in the zeros, they are the host portion. If a PC belongs in the same network as other devices, they share the same network or subnet. So in the diagram here, if PC1 needs to communicate with PC2, it will do a DNS lookup for the IP address of PC2. Let's say the example here gives the IP address of PC2 as 10.1.1.20. So now PC1 needs to determine whether PC2 is located in the same subnet because this will determine whether the frame has the MAC address of PC2 or the MAC address of the default gateway, which means it has to send the packet on a different network. So how does PC1 do this? So it compares its own IP address to its subnet mask in binary, like this diagram. This will result in PC1's network or subnet ID. Now let's compare PC1's subnet ID with PC2's address in binary. They have the same subnet portion. Because the binary bits are the same, then PC1 concludes that PC2 is in the same network or subnet. That means PC1 can communicate directly with PC2, and it does not need to send the data to its default gateway. So then PC1 creates a frame with its own source MAC address and the MAC address of PC2 as the destination. So now let's consider if PC1 wants to communicate with a web server at the IP address 192.0.2.1. Just as before, PC1 needs to determine whether the web server is located in the same network or subnet. So it will do the same calculation as before and get the PC1 subnet ID and then compare it to the subnet ID of the web server. In this case, they are not the same. In conclusion, the web server is in a different network or subnet since the bits are not the same. Therefore, to communicate with the web server, it needs to send the data to its default gateway. So now PC1 will create a frame with its own source MAC address and the MAC address of R1 as the destination. So you might be wondering if there is a shorter way of determining whether two PCs are on the same network. So you look at the subnet mask. In this case, the subnet mask for PC1 and PC2 is /26 in the CIDR notation or 255.255.255.192 in dotted decimal notation. So we take the most interesting octet from the subnet mask. In decimal, this is the last octet that has a value greater than 0. In this case, this will be the most interesting octet, which is the fourth octet. So we take this number 192 and subtract it from 256. We get the result of 64. So that's how big the block of addresses is for this network. So for example, we take the first block. The first block will begin from .0 and ends at .63. The second block will begin from 64 and end with 127. The third block will start from 128 and end at 191, and so on and so forth. So if we look at this PC, PC1 and PC2, the IP address is .74, and for PC2, the IP address is .20. We look at the block size, it's supposed to start with .0 and end with .63. So this means PC1 does not belong to within the same network as PC2. But we look at the settings here. The default gateway is both 10.1.1.1 for PC1 and PC2. That means it's meant to have or to be in the same network. So now we need to change the IP address of PC1 to any number between 0 until 63.